students, those who are preparing for NET competitive exams and for the PG chemistry courses. At first year level, there is important aspect of the group theory under the inorganic chemistry. That group theory is not only applied for the molecules to study their hybridizations, rotations, reflections, and vibrations, but also that theory is useful for determination of spectroscopic transitions and quantum properties studies of the molecules. So here today I will discuss in deep and detail about the group theory application to water molecule, how group theory points and the parts are applied to the water molecule to determine its spectroscopic transitions and bond rotations, vibrations, reflections or bond transitions. So let's start our discussion with these handwritten short notes. So here group theory is such a theory formulated by Schoenfly in which the molecules their hybridizations are related to the symmetries, molecular symmetries, and molecular symmetry is important aspect to decide changes in the molecular hybridizations when quantum energy interacts with it or radiation interacts with the molecules. So here, as per the group theory, water molecule has the point group C2v. And what are the C2v point group applications? Means which type of a transition takes place for the C2v like molecules, C2v point group molecules. Today we will discuss that. So water, you know that universal solvent, it is important molecule in inorganic chemistry, as well as it is the biologically important solvent. So water gives the scattering in the sunlight. That's why sky is blue. That is observed by the Sir C.V. Raman, Indian Nobel laureate, great scientist. And from the scattering of the light from the oceans, the ocean become blue. Means it is the Raman active molecule under his spectroscopy, Raman spectroscopy. So let's study that in detail with respect to group theory. So here water water has hybridization as sp3. It has disordered tetrahedral structure or V-shaped structure. The bond angle is 104 degree 28 minutes. Water contains two lone pair. Suppose the two hydrogens are symbolized or named as H1 and H2. The water has a symmetry as according to the disordered tetrahedral or V shape. Water has symmetry elements. The Schoenfly has given symmetry elements of the molecules are identity E, axis of rotation Cn, or improper rotation reflection axis Sn, where N are the folds of the rotation, sigma are the planes, sigma H, sigma V or sigma D, that is sigma horizontal plane, vertical plane or dihedral plane or diagonal planes is present in the molecule. So water possesses some symmetry elements and their symbols for their symmetry operations as water has sp3 disordered tetrahedral hybridization V shape. Water contains the symmetry elements E identity means self hybridization, C2 that is twofold axis of rotation for the H1 and H2. So water has a C2 axis that is passing through Z axis if water hold at lone pairs vertically. Water has two vertical planes of symmetry as sigma V and sigma dash V, that is sigma xz and sigma yz, because when the plane passes through lone pairs it is one plane, and if it passes through hydrogen it is the another plane, and that planes are the sigma V and sigma dash V. So that is sigma xz and yz. So water has four symmetry elements E, C2, sigma V and sigma dash V. The water has E, C2 and 2 sigma V, two vertical planes up there. The horizontal plane in the water is absent, diagonal or dihedral plane is sigma D is absent. So water has symmetry elements E, for that identity self hybridization operation is there. Water regains its identity after reflections or rotations. Water has C2 twofold axis of rotation operation performed H1 to H1, H2 and H2 to H1. the rotations can be performed. Water regains the identity by square of this C2 square gives identity. Sigma v is the vertical plane. Suppose that is the sigma v intersects the water molecule when the hydrogen remains aside or lone pair remains aside, that is the sigma v. And if the second vertical plane passes through the lone pairs, it divides the two hydrogen which are mirror images of each other. So that is the secondary plane of symmetry, that is sigma dash v along y and z axis. So as these are the symmetry elements of the water, so according to that E, C2 and 2 sigma v, the point group of the water according to Schoenfly will be C2v. That is the C2v point group according to symmetry elements and operations. So next point we have to study, that is symmetry element matrix representation or matrices of these water symmetry elements. So first symmetry element, that is the identity for the same hybridization, no change operation. Here the matrix 2 by 2 matrix can be represented for the x and y axis as water is held at z axis, that is 1 0 0 1 for x1 x2 and y1 y2. That is total product will be the value of this matrix will be 1 minus 0, that is equal to 1. So identity matrix can be represented like this, or if three-dimensional representation is there for the water along x y z axis, then diagonally there will be 1 values for identity and total value will be 1. No change operation, identity self hybridization. Second C2, the twofold axis of symmetry. Twofold why? Because 360-degree rotation divided by 180 for the two hydrogen, 180-degree rotations, that is total n is equal to n fold means that is twofold axis of symmetry C2 for the water along the z axis. So water can be 2 times rotated, that gets the identity. So here n is equal to 2, and for the C2 the change occurs when the hydrogen rotates. So value in the matrix can be represented as 1 0 and 0 to minus 1. So total value will be minus 1 axial change for the C2 axis. Next symmetry element and matrix presentation for this water will be sigma v, that is sigma xz, and here when reflection occurs sigma v can be represented 1 to 0 or 0 to minus 1. The value will be minus 1. If 3 by 3 matrix is taken, the values will be 1 0 0 0 minus 1 1 or 0 0 1 for the z along z axis. So planar change occurs, the value will be minus 1 here. And for the sigma dash v, the next symmetry element, that is sigma x y z here, so passing through the lone pairs, the plane passes vertically through lone pairs. The 2 by 2 matrix will be minus 1 0 and 0 1. The value will be minus 1. If 3 axial form is taken, planar change for this plane, minus 1 0 0 0 1 0 0 0 1. So value will be minus 1. If here sigma v represents total value minus 1, sigma dash will have 1. If sigma v is representing 1, the sigma dash will be having value minus 1. So these are the matrix presentations of water symmetry elements and their respected operations. Now next part of the group theory we have to use, we have to determine multiplication table of the water. The multiplication table and the presentations according to presentation, reducible or irreducible presentations can be represented as like this. The multiplication table for the water will be water's symmetry elements will commute means multiplied. When multiplied, that gives the different identity or same hybridization. So the symmetry elements are commuting. Here inverse will be getting with the identity, so value will be 1 for the water. Association law also will be performed by the symmetry elements of the water. So association means when one symmetry element multiplied to another, that gives the different symmetry element, and when the square of the multiplication table symmetry elements is taken, we get the identity. So here associative law also can be performed with the water. The multiplication table consists of the symmetry elements and related symmetry operations, 4 types of the symmetry elements, 4 types of the symmetry operations can be obtained from this C2v multiplication table. Diagonally we get the same uh, the symmetry elements. Look here, identity is diagonally same. Diagonally C2 CT are there. Diagonally sigma V are there. Diagonally sigma dash V second planes are there. And alternate commutation and association occurs. So reverse terms are obtained for symmetry element at the last rows and the columns. So this is the multiplication table. It elaborates the reducible and irreducible presentation. Reducible presentations means which can be further reduced, and irreducible means which cannot be further reduced. That are the combination vectors for the transitions of the waters under the spectroscopic transitions. So reducible presentation for C2v point group of water, the values are 3, -1, 1, 1 for 3 for identity, diagonally 1, 1, 1, and -1 for C2 axis. For sigma v, that is 1. For sigma dash v, that is also 1. So here irreducible presentations obtained from can be obtained from these combinations, and irreducible presentations can be represented using orthogonality theorem, where orthogonality theorem, the order of the group xi, or that gives the values of the order of the group, or number of the Mulliken symbols, or number of the irreducible presentations, means number of the vectors or transitions present in the molecule. For C2v there are 4. Why? Because xi when multiplied with the reducible presentation matrices of the symmetry elements, we get the values like the 1 square minus 1 square plus minus 1 square plus 1 square. So total values will give 1 1 1 1 additions or summations giving 4. So according to great orthogonality theorem, water consists of the 1 minus 1 minus 1 1 type of the presentations for the symmetry elements and their operations. That symmetry elements are the EC2, sigma V and sigma dash V. The total value is equal to 4, and 4 types of the combinations will be there, that is irreducible presentations. So that can be that presentations using this multiplication table and the according to orthogonality theorem can be represented in character table. Character table of any point group under the group theory is representing the number of transitions taking place, or no degrees of freedom of rotations, vibration taking place in the molecules. So for the C2v water type of the point group, here the character table will be like this, and here A1, A2, B1, B2 are the Mulliken symbols for irreducible presentations, that is combination vectors or degrees of freedoms. So here the reducible values are obtained as for the symmetry elements EC2, sigma V and sigma dash V, as for A1 1 1 1 1, for A2 1 1 minus 1 minus 1, for B1 1 minus 1 1 minus 1, for B2 1 minus 1 minus 1 1. What are these A1, A2, B1, B2? There are two types of the degrees of freedoms splitted as A1, A2, B1, B2. Means according to great orthogonality, 4 order is there, fourth order is there for this point group. So 4 types of the transitions are possible according to character table, which are resulting to E, C2, sigma V and sigma dash V. So these are the rotational translation vectors here, Z, RZ, X, XY, Y, RX. For X that is the RY, for Y that is the RX, and the rotational vectors X square, Y square, Z square, and for RZ it is XY, for RY it is XZ, for RX it is YZ. So in this way character table of the water can be represented. The water's point group is abelian or non-abelian, that we have to decide. Abelian point groups are in which the operators or they are the functions of the symmetry elements commute means that multiplies and gives the identity, or that when that are 2 times of the symmetry elements are performed, we get the identity. So here all these symmetry elements in the C2v commute, so that's why it is a abelian point group. If that do not commute, the point groups will be non-abelian. So as it is abelian point group, we have to study further its molecular symbols A1, A2, B1, B2 and their meanings. So finally, this total concepts of multiplication, character table, symmetry elements can be applied using mathematics, matrix presentations to the spectroscopic transitions that is happening in the water and quantum interactions. As E is equal to h nu photon when interacts, light radiation interacts with water. Water is a point group is abelian. It has have the degrees of freedom according to formula, as it is the non-linear molecule 3n minus 5, that is 3 into 3 atoms minus 5. Four types of the transitions are possible in spectroscopy for the water, but there are three active transitions in the water. Two are IR, one is the Raman. Let's see how according to molecular symbols in the character tables. So in the IR spectra, water gives the two signals at 3400 means 3400 centimeter inverse frequency. One broad peak will be obtained for the OH functionality of the water, and one bend peak will be obtained at the fingerprint region. So IR, two signals are possible, two transitions are possible. Let's see here. When stretching takes place in the water, when radiation interacts with low energy IR energy, the water shows the symmetric or asymmetric stretching. So for that, A1 millikan symbol is represented in the character table. Means all the values of symmetry elements are 1, 1, 1, 1, 1. Reducible presentations. So irreducible presentation, A1 millikan symbol. So that is the stretching type of the vibrations of the water, symmetric or asymmetric. That is A1 IR active transition. And B2, that is the last transition where the reverse changes occurs 1 minus 1 minus 1 to 1 for the symmetry elements. That will be the bending transition in the IR radiation for the water, and the molecular symbol is B2. So these are the two active modes of the IR for the water. And in the Raman spectra, the sharp bands will be obtained, two bands, combined bands converted into one band at high energy interaction of visible radiation to the water. Water gets molecule gets scattered by that photons, and that scatter in the blue region. That's why sky looks blue according to Sir C.V. Raman, the great scientist, Nobel laureate, which explained that in the Raman spectroscopy. So two types of the transitions are Raman active for the water, A2 that is wagging and B1 that is twisting. But combination gives only one mode of the water's rotations and vibration. So at high energy it is Raman active for one mode, and two types of the molecular symbols in character table represents A2 wagging, B1 twisting, like this. That is A2 and B1, where 1 to 1 minus 1 minus 1, 1 minus 1, 1 minus 1 values are there for these symmetry elements. So in this way, the group theory, all the concepts step by step give the application towards the spectroscopic and quantum transitions, quantum properties of the molecules, which is elaborated here using water molecule. Thank you.